Okay, hello everybody. So my talk it's also the condensed version of a 1 hour talk that is much more understandable. But it has two parts, and I thought in the beginning that I should maybe focus a little bit more on explaining what I mean by explainable search, because the peer project that is based on it is not so much focused on games, so it might be slightly less interesting for you. It's one of those evil real world applications. But now we've already heard quite a bit about explainable search, so maybe I'll talk more about the project. Let's have a look. Let me know what you think. Would be great if, like, where exactly? Here, okay. Okay, right. So again, I am interested in explainable search. I think in 2020, I wrote a vision paper on it, describing what I would like to do there. And what's the basic question underlying this direction is we have search-based agents, search-based AIs. How can they explain their behavior? I'm using also a chess AI here on the slides as an example, because you guys understand games and for some of the reasons that Ingvi just described. But algorithms that involve search are also used in a lot of slightly higher stakes applications and with increasingly more autonomy, which is why we would like to understand what they're doing. It was also briefly touched upon, but I want to mention again, there is a huge field called explainable AI nowadays. And so what makes explainable search special or different, or why can't you just explain it with out-of-the-box methods that come from elsewhere? This is very simplifying, but basically when you look into explainability, you see two major groups of work out there. There's a lot of work that just tries to explain single decisions of agents that don't actually do search. They just have a neural network, for example, that outputs a decision. And Ingrid mentioned that it's model interpretability, really, what they're doing. But in a sequential decision-making domain like chess, that's not really helpful. So even if I have a great method to highlight which pieces on the board were the most influential input for my move decision, for me, that would not be enough explanation, because I would want to know, okay, but why are those pieces important? So what's going to happen next? Like, what are you scared of? Or, what can the opponent do, etc. But then there's also quite a bit of work on explainable reinforcement learning, where the goal they set themselves is we want to characterize the entire policies of an AI agent, which means all of the behavior the agent is capable of, so that humans can judge if they trust it or not, and things like that. They do this, for example, by collecting lots of typical behavior examples and then just show them to you, and then you can get an idea of what kind of thing this agent does or doesn't do. But chess is too complex to try that. If I have a question about why I should make this move, you can't start explaining to me how you play chess. That's not the question. I want to know about this move, right? So there are a lot of challenges involved here. It's great that Ingrid specifically mentioned one that I left out here, and that is the integration of that. We need to explain search, but we might also need to explain the model that is used inside the search, right? Because the state-of-the-art algorithms use both. They use sort of symbolic system one thinking with search, and they have the system two thinking, or I always confuse the two, with the neural networks built in as well. There's lots of other challenges that I find interesting. So for sequential decision-making domains, it's even more important than for other domains that explanations have to work as some sort of conversation, because there is no one-size-fits-all explanation that makes everybody happy and then there are no further questions. That never happens between humans. That will also not happen with AIs. So if the AI says something about there's the main threat is there and there, then you might still have a different idea how to face that threat, and you want to know why that's not a good one, and so on. Then what makes this even more interesting is that in these conversations, you also need to allow explanations to flow both ways sometimes. because chess and other very complex decision-making problems that I'm interested in can't actually usually be solved to optimality unless you're in some end game position that has been solved. The AI also doesn't know if it has the perfect move or not, and it cannot prove to you that it has the perfect move. It just has the best move it could come up with based on the trained neural network, the MCTS search, et cetera, So maybe the AI is very strong and is most of the time better than the human, but maybe the human is actually grandmaster and the AI actually has no idea about certain things because they're not well reflected in its heuristics or whatever it has learned. So you might want to accept some feedback from the human as well. Maybe the search algorithm has to accept some answers like, oh, you might want to explore this branch of the search tree a little bit deeper. You might not have looked at that enough. So what happens then here is not so much explainability, it's more human AI collaboration. Yeah, what happens here is we have the same goal. We want to figure out what's the best move here. Let's do this. It really depends on the setting that we're in. Then conversations are, they proceed over time. Chess games proceed over time. So you have long-term interactions. And maybe if you are in a teaching situation, this long-term interaction goes even much longer than just one game of chess. Maybe you want to teach someone chess. So maybe then you have a long-term interaction over 100 games with them to teach them various concepts. So your explanations also have to take into account what you've already explained before, what the human already knows, how the human's knowledge develops over time. You can't explain every move the same thing again and again. So I gave an example here where the AI refers explicitly to an explanation that it has given before, and it says, well, the plan that I wanted to do is still valid, but the opponent has just delayed me a bit. So after 2 moves, we're getting back to the plan, which, I mean, goes way beyond what we can currently do. And then you can also integrate your knowledge that you're going to have to explain things into the search process itself. So if you want to teach somebody chess, then maybe you shouldn't start a super complex strategy to begin with if you know that the student is not at that level yet. So depending on whether your goal is, maximize performance or your goal is maximize, learning progress of the student, it depends. You might not want to just play the best move that you can find. You might want to actually consider what you have to explain later, and then maybe pick a move that you can explain, or that you can explain to that specific person based on what they know. And this can, I was also I explained it all based on chess now, but there are also good reasons to do this kind of thing if you are collaborating with the robot in the field and it's a high stakes situation, and the human operator is supposed to be able to ask the robot what it's doing because it has some sensors, it is inside a house, it sees some things that the human is not seeing, etc. Then you don't want super complex explanations because you don't have time. Time is the most important currency then. So if the robot can come up with a simpler plan that is more quick to explain, then it should do that. So what I think explainable search is, I'm still calling it explainable search because I need the word search in there, and some of it might even be process explanations in the end, but not for the end user. That's normally not interesting. You're right. Explainable search has to be an exploration of the possible futures that might be already in the search tree, or they might not yet be, but you might need them for your explanations. How you evaluate those possible futures, how they're related to each other, and what your choices are, how to influence them. You would like to explore that together with the user. And if we can build agents that can explicitly reason about these spaces of possible futures, then we can become better at effectively collaborating with users by continuously, over the course of a sequential decision-making process, searching, communicating about the results of the search, and learning from what has happened in the conversation. And now I'm getting to a not games related part, and I'm showing you the project that Bart was hired for, even though he's an excellent chess player, and we're also definitely going to do something in that direction. We have some real-world explanations here where we would like this technology to work out as well. So we would like it to be quite generally applicable. And what this project is doing, it's trying to tackle complex sequential decision-making tasks that involve close collaboration of humans and AI. Like, for example, routing problems in logistics, manufacturing process control, and various other problems that people are solving with AI, or that people are trying to solve with AI, but they run into problems because the employees don't accept the AI. The employees either don't listen to the AI at all, or they always listen to the AI without thinking about it, and both doesn't really work out. So the EU is very interested, of course, in a human-centric approach to AI. And the problem is, in these tasks that have these sequential decision-making characteristics, there's a lack of mutual understanding between AIs and users. So users don't understand AIs very well because the explainable AI part is missing. But also AIs don't understand humans very well because they are not adaptable enough to the actual user needs. They don't adapt well enough they don't do user modeling well enough. Right, so the ambition of this project is quite large, and my part is the human-centric AI methods for sequential decision-making settings. That's the work package I'm leading, but we are systematically actually attacking this problem also already in the design phase of AI, all the way down to the evaluation phase. So there are researchers interested specifically in design. How do you design sequential decision-making AI? It's very difficult to work with that as a design material because you can't explain to people what it is that you're going to produce, and they can't very well explain to you what they want from it. It's very difficult to create prototypes or things that you can show off. And then we also want to, in the end, evaluate and assess whether we've made any progress on topics such as trust and AI acceptance. And we don't have an agreed on framework for how to do this. And I want to show you now, in the end, just one of the 4 application cases that we have, and one that we're probably going to start working on. The municipality of Amsterdam is interested in building a personalized routing system for people with disabilities to make the city more accessible and more inclusive. So the problem is, when you use Google Maps to go from A to B, like most people, you get the shortest or the fastest path. Now, for people with different kinds of disabilities, that is not interesting at all. And this is a very, personal question. Which paths are you able to take? Which paths are you able to take on that particular day? Because you feel like you can handle this now, or you can handle it, you cannot handle it. We had some workshops already with user groups there that said that this is quite a personal decision. It can depend from day to day. What incline can I handle with the wheelchair? How wide does the path have to be for me to fit through, et cetera, et cetera? And unfortunately, when you navigate the city, there's a lot of this happening. So the path planner tells you that this is the plan to go, you should go through there. But you can't very well tell the current path planners, no, I can't go there, there's bikes, right? And I could only go there if I'm going on the street, and I'm not comfortable with that. So we see that we have a sequential decision-making problem to solve, and we need to do it in a collaborative way. And we need to do it in a way that involves a lot of understanding, user modeling, but also understanding of why the AI is proposing a certain path, right? A lot of trust is involved to even start using an app like this. So the city has a data science team, and they have started to create these 3D point clouds of the public space to measure where more permanent obstacles could be located. So, for example, cafes putting chairs and tables outside and things like that. Google Maps doesn't know that either, but you can map that. And then they're also going to start to, they have a crowdsourcing project where people can label accessibility issues, and they're going to start to measure like how high are the curbs and things like that. And then in the end, we want to build an AI that makes this personalized route planning possible, starting from this kind of data that they have, but then going much more into the user modeling, modeling of user requirements and preferences, and also this collaborative work, explaining corrections from users based on the dynamically changing environment. Yeah, and so this is the fancy sounding conclusion of what the project really wants to deliver in the end: interactive, understandable, and trustworthy sequential decision-making AI systems that expand the user's agency. And we do this with flexible, personalized solutions that are adapted to their requirements and capabilities. And my part for that is explainable search, pretty much. Some of the application cases have to do with more classical AI planning. Some of them have to do with more like MCTS style planning. Some of them have to do with path planning and so on. And we have different AI teams involved in this that have that slightly different background and interests, but that's overall the goal. Yeah, and so the team that's going to make this possible: Bart, the person who's going to do the actual work, and somebody who is going to help you with it who hasn't joined us yet. And then together with AI partners in various other European countries and different use case partners as well. So that's going to be my excuse to do explainable search.
Yeah.
Okay.
We accept your excuse, I think. Thank you very much for the talk.
Any questions?
Yeah. Not so much a question as an observation, but one of the things what the work project proposal for training for first responders in receiving emergencies, and even the game side of it. But one of the problems and the issue where explainability goes to address it is that if those people are trained to respond. They're traditionally trained to respond in certain ways.
Mm-hmm.
And if you want to give them a scenario or an AI or a tool or something that's going to say, no, don't do that. Do something different because it needs to be explained to them very quickly. You should do this differently to your years of training because this reason in a convincing way, which makes the explainability thing. Obviously, a lot depends on the pace at which you're moving.
Yeah, it's easier if you're not in a real-time situation where you have to very quickly explain things, because it's hard to be very convincing if you have to be also very quick. And then there's also recent work I find very interesting from Tim Miller, where he found basically people don't really accept explanations anyway. If you give them like in this way, if you tell them, hey, you need to do this, and if you're interested, here's also some explanations why you need to do this. People don't respond to that very well. They don't really engage with the explanations. They don't really understand the explanations. What people engage with more is when you say, hey, I help you explore your space of choices. Which choice do you want to talk about? Like, which options are you interested in? You're interested in this option? Okay, here are some arguments for and against this option. Think about it. Here are some arguments for and against this other option. You make the choice. And this is something that humans like a lot better because they feel like they are in the driver's seat, like they should be.
Maybe, do you have any person working in linguistics and interaction in your groups? Because one explanation why people don't like, I'm doing this, this is the first explanation, it's because it don't follow human interaction, which are more like you have to balance participation. And so if you have a huge amount of text, people will reject it because it's not a good way to participate. Like lecture and lesson, it's not a good way to participate. Usually if you do the same thing during an interaction, people on the other side will be like, oh, this person is annoying, he's talking too long.
Yeah, at least if you didn't ask for the long explanation.
Yeah, especially if you didn't ask. So there are ways when we are interacting with people to have base explanation or obtain base explanation with some sort of rhythm of sequentiality as you use that are known in linguistics. So that might help you to identify, okay, how can we have more of an interaction rather than an exposition of what we have to do. That
Yeah,
would be, I think, helpful to like simplify the explanation.
yeah, because this explanation situation is a social situation also, that people have certain expectations how that's going to go down. I'm not even a human-computer interaction expert, much less a psychologist. But that's why this is a very interdisciplinary project as well. And I think problems like this will be discussed we have co-creation workshops with the future users, where the social scientists in the project are sitting down with them, and they create, cardboard fake explanations that the AIs could give, and then they say, okay, how would you feel about this? And how would you feel about that?
And do you have any person in linguistics, like in a conversational analysis field more recently? That would be helpful, I think.
I don't think we have that. Yeah, a lot like cognitive scientists could also be helpful. A lot could be helpful there. Yeah. Well, we've already found some interesting. I mean, starting from the users is really the most important thing. Of course, I'm trying to squeeze the research in here that I want to do, but for the product, for the deliverable in the end, we really need to start with the users and what they actually want. For example, we thought this navigation app would be on a phone, right? Well, not really. So the users say they would really prefer audio because they're not going to get the phone out when they're on their way with the wheelchair somewhere. Or like if they use crutches, they can't, literally, right? So maybe we're going to have to tackle audio interfaces for this. And it's really challenging because how do you explain a heat map or something like traditional explainable AIs with audio? Very difficult, right? So you have to be then extremely selective about saying things like, you could go this street, but it has this downside, and you can go this street, which I think you would like better, but it also has this other downside. So make your choice. You have to really condense. That's it.
The slide I really liked was where the computer was thinking that this is not the right answer for this student at this time, which I think is applicable to teaching anything in terms of like conveying feedback, because an expert system and an expert AI system that are deeply knowledgeable about classical games can sort of dump an explanation upon someone. But,
that Ryan was saying that I'm not taking this plan because I'm not able to
explain to you.
It's not just like it's not just he modified the explanation, he modified
The plan itself.
so that was quite an interesting.
Because I think that's very. I mean, having been in classrooms where people, fail to do that, they talk at people, they talk at students, and they don't actually interact. So I think that's a very important thing.
Yeah, explanations have to be personalized. They're always based on what you think the other person already knows or already assumes, right? And I mean, I haven't taught chess, but I very much assume that you don't learn chess by starting with the grandmaster games and just reading them. Like you have to start with basic things, right? Okay. I guess that was it. Yeah.